This is lesson 13, and today we are going to talk about creating methods in Ruby. So first of all, let's talk a little bit about what is a method and why we need to use it. The method is basically a collection of Ruby commands that we want to package, if you want, inside of a whole that we can then use with a single command. So how do we create a method? And let's see what kind of things we can do with it. We create a method by using the define keyword in Ruby. So let's create a method called hello, and this method simply puts the command, the word hello, on the screen. Let me save that and let me run this, and you're going to notice right away that when I do that, nothing happens on the screen. And the reason for that is that unlike the commands that we have used in Ruby before, when we define a method called hello, it does not automatically get used or executed by the code. We actually have to explicitly call this method to make sure it gets executed. In other words, we have more control over what commands are being executed when in our program. How do you call then the method hello? You simply use the word hello in the program. We will see a little bit later on that there is such a thing called parameters you can send to a method, which we are often used between parentheses. And I think it's actually a good thing for you at the beginning, at least, once you're learning methods, to always put parentheses when you call on a method, just so that you don't forget to actually what exactly you are doing when you're using the word hello. So in this case, when I run it now, what happens is we've defined the method hello, and then here we're calling the method hello, which at this point starts executing the commands inside of it and puts on the screen the string hello. So if that's all we could do with a method, it would really not be that useful. The two principal reasons for a method is that it allows you to really organize your screen, your code much better. But the other thing that it's good for is that you can basically write a piece of code that performs different type of function based on different types of input. So we're going to modify it now. Hello, and the way we're going to modify it is that we want to actually say hello to someone in particular. So here we're going to say we would like to say hello to Bill. And you'll notice what I do is that when I call the method hello, I pass it the string Bill. I tell it that the person I want to say hello to is Bill. Now, how will the method hello then know that the person I want to greet is Bill? Well, we use a symmetrical construct as part of the definition of the method hello, which is that we open parentheses, and inside of the parentheses we create a local variable. This is very similar to what we've done in our programs with blocks and what have you. We create a local variable and we call it name, and what happens is when we actually call hello Bill, the string Bill will automatically get assigned to the local variable hello. What we can do with that now is that we can then say hello, and then we can use string interpolation to actually print the name of the person we want to say hello to. And when I run now the program, it says hello Bill. So as I said before, one of the advantages of having methods is the fact that it just allows you to kind of build some logic inside of a function essentially, and then organize your code in a way that makes it more readable. So if I wanted to say hello to two people, I could call the same method twice like this and say hello Bill and hello Jane, and without having to replicate the logic of what it takes to say hello, I could simply get this to show up twice on screen. Again, in this simple example, it may not feel like this is much of a gain in order when you have a method, given that the method itself has just one line of code. So we're going to add a little bit of logic to hello to make it more complex. And what we're going to say is that we are going to add a second variable, a second parameter called language, and then we're going to put some logic inside of the method hello to determine in which language we say hello to a person. So now I'm going to say if the language, remember language is a local variable inside of the method hello. If the language is equal to English, then we want to say hello. And if the language is French, then we will instead say bonjour. And now you can start seeing how the complexity inside of the method is something that we would actually not care to replicate for every time we want to say hello to someone. So it's nice to actually put it in one place and have this logic being reused in different contexts for different names. So if we wanted to say hello in German, we would say Guten Tag. And I can even put a little error statement saying, don't know this language. Make sure that I end this. Okay. Now, let me actually run this right now. It's not going to work, and the reason it's not going to work is because you'll notice hello says wrong number of arguments. One was given, Bill in this case. Two were expected. I did not specify the language in which I wanted to greet Bill. So now I'm going to say that I want to greet Bill in English, and I want to greet, well, Jane will become Jeanne, and she would like to be greeted in French. And when I do this now, then you will see now that we say hello in two languages to two different people. Okay, the other thing that we want to remember here about methods is talk a little bit more about what's going on with these local variables. You know, I said that name and language were local variables to the method. What we mean by that is that name and language only exist in the context of the method hello. So if I were to here say puts name, for example, thinking that perhaps it's going to pick up the last value that was assigned to the variable name inside of hello, it will not work. It says undefined local variable. Why? Because the context in which name was defined is the method hello, and we are actually trying to write it to the screen here outside of the method hello, and that will simply not work. So let me actually try a different example of that to try to illustrate the point a little bit further. And what we're going to do is that we are going to define a method, foo, and it's going to take two parameters, a and b. Okay? And it's not going to do anything very fancy. It's simply going to say a equals 3, b equals 4, and then we're going to say puts, and we're going to write on screen a equals a, b equals, sorry about that, b. Okay, let's clean this up. Okay, and then, so you notice I've defined the function, but I've not called it yet, right? So if I actually start writing some code here that says a equals 1 and b equals 2, and then I actually print this on screen, it's going to print 1, 2. After I do that, I'm going to call on foo of a comma b. So this is basically step 2, right? If this is step 1, This is step 2. And then after I call foo of AB, I am actually going to print again the values of A and B on screen, step 3. And you will see, this is interesting what happens here. When I go to run this, let's examine the result. As we expected, nothing happened when we defined the function, but we said A equals 1, B equals 2, and we printed these values on screen. That's here, step 1. Then we called on foo, so we passed to foo the values of A and B. So we passed it 1 and 2, but essentially they were received here in foo, but we actually reset the values to 3 and 4 before we printed it. So we see that A equals 3 and B equals 4. But this is where it gets interesting. When then I finish my work with foo and I come back out of foo and go into line 26, the values printed on screen of A and B are back to 1 and 2. And the reason for that is because changing the value of A and B happened here in the context of the method foo and only changed the local copies of A and B as opposed to changing the values of A and B outside of the method. In other words, there are 2 A's and 2 B's. There's an A and a B outside of the method foo, and there is an A and a B with the same name but which live only inside of the method foo. The last thing we're going to talk about today in terms of just what a function can do is that we're going to look at the fact that a function can actually return a value. And we'll just do a very simple example today. We're going to use the keyword return and say first that bar returns 2. And what that allows us to do is to say I want to actually assign to the variable x the value bar, as in call the function bar and then print the value on screen, put into x. And when I do that, you will notice that x is 2. And that's because we called bar, it returned the value 2. So essentially the call of bar was replaced by the value 2, which was then stored in x and then put on screen. Similarly, what I could do here is I could create a parameter, and I could say I want to do bar of 5, and then here on purpose I'm using the same letter even though we've already seen that this letter x is different from this letter x. So bar takes a parameter called x, and we're going to say return 2 times x, and x equals bar of 5. So 5 will come here, we'll return 10, and we'll put it on screen. And again, I'm going to run this, and you will see that the value printed is 10. So methods, we create them with the word def. We can create local variables for parameters which live only in the context of this method. We can then call the methods using parameters between parentheses. And finally, we can use the keyword return to send a value back out of the function to the part of the program which called that function. This is lesson 13.